In this video, we are going to talk about square roots and cube roots. So let's begin. Squaring a number is raising that number to the power of 2. So you're raising it to the power of 2 or to the second power. When a negative value is squared, be careful to note whether or not the negative sign is inside the parentheses. Observe the differences below. So for example, when we've got this right here, negative 2 inside parentheses squared. What that means is negative 2 times negative 2. And what that is, negative 2 times negative 2, is 4. Notice it's positive. So negative 3 times negative 3 is 9. It's positive. Negative 4 times negative 4 is 16. Also positive. Let's take a look at this negative 2 square. What this is actually, probably better written like this. It's like negative, and then you've got 2 square, like that. And that would actually be negative 4. The reason for that has to do with PEMDAS or GEMDAS or whatever you want to call it. Different people have called it, where you've got parentheses, exponents go next, and then multiplication, division, addition, subtraction. Technically, it's like this negative right here is being applied to the, it's almost being like multiplied or divided, but it's being applied to the 2 square afterwards. So you would do the exponent first. So you would square the 2, and then you would make it negative afterwards. So that would be negative 4. If you've got this negative 3 square, no parentheses, that was going to be, you do 3 square first, which is 9, and then you make it negative. You have 4 square, which is 16, and then you do the negative afterward. So just be aware of that. Squaring let's look at the next one. Squaring a number. We're talking about squares and square roots now. Squaring a number is the opposite of taking the square root. So squares and square roots are opposites of each other, or they're inverses. You could have said inverse of taking the square root. They're inverse operations. Taking the square root of a number technically results in 2 solutions. For example, 16 equals 4 or negative 4. Because, well, if you think about it, 4 times 4 equals 16, but also negative 4. Whoops, that wasn't very clear. Negative 4 times negative 4 also equals 16. I could have also written 4 square or negative 4 square. So they both equal 16. So the square root of 16, if you ask what 2 numbers equal 16, or what number times itself equals 16, you would say 4, because 4 times 4 equals 16. Or you could say, well, negative 4 times itself, because negative 4 times negative 4 also equals 16. So technically, a square root, every square root will have 2 answers. We can write this as the square root of 16 equals plus and minus 4. So often you'll see the plus and minus 4, not just 4. The positive square root is known as the principal square root. So oftentimes when we say things like, what's the square root of 25? We'd say 5. And that's because it's known as a principal square root. Technically, it's plus and minus 5, but we just say 5. We go with the positive number. Let's talk about cubes and cube roots now. Cubing a number or raising a number to the power of 3 is the opposite or inverse of taking the cube root. So raising a number to the power of 3 is cubing number, and then taking the cube root is like the opposite of that. So it's like a square root except with cubes. So for example, this is called the cube root of 8. For example, cube root 8 equals what? What times itself 3 times equals 8? Well, 2 times 2 times 2 equals 8. So the cube root of 8 is 2, because 2 times 2 times 2 equals 8. Or you can say because 2 to the third equals 8. right? So cubes and cube roots are opposite. Can a cube root have a negative solution? Explain why or why not. Now, a square root can have a negative solution. Like square root of 16 could be 4 or negative 4. Square root of 25 could be 5 or negative 5. But can you have a negative solution for a cube root? Well, let's see. If you had negative 2 times negative 2 times negative 2, that would equal negative 8, right? It would equal negative 8. So can you have something like this? Yes, you can, because square root of negative 8 is negative 2. Now, that is different from a square root, okay? Because a square root, you can't have a, for example, negative 9. You can't have the square root of negative 9. That's technically impossible, because what number times itself equals 9? It's not 3 times 3, because that equals positive 9. And it's also not negative 3 times negative 3, because that's also positive 9. So cube roots are a little bit different, where it's okay to have a negative number inside the cube root. It's not okay to have a negative number inside of a square root. That's going to create an imaginary number, which we don't have to worry about. All right, so let's go ahead and fill out some tables of squares and square roots. Perfect squares. Let's see. 1 square is 1. 2 square is 4. 3 square is 9. 4 square is 16. 5 square, 25. 6 square, 36. 7 square, 49. 8 square, 64. 9 square, 81. 10 square is 100. All right. Cube roots. This I'm going to have to pull my calculator out for. 1 to the third is 1. 2 to the third is 2 times 2 times 2, which is 8. 3 to the third, I know this one, 27. 4 to the third, that's 4 times 4 times 4, which is 64. 5 to the third, I believe that is 125. 6 to the third, that one is tricky. It's 36 times 6, which ends up with 216. 7 to the third, well, that's 49 times 7. That's 343. 8 to the third, that's 8 times 8 is 64. Times 8 again is 512. 9 to the third, well, that's 81 times 9, which is 729. And 10 to the third, no, that's easy. That's 10. That's 1 with 3 zeros. So at least 10 to the third was easy. All the rest were kind of tricky. All right, let's go ahead and evaluate the following squares and square roots. All right, what is negative 7 times negative 7? Well, it's negative 7 times negative 7, which is 49. 2/3 squared. Well, that's 2/3 times 2/3. Notice when you do squaring of fractions, you got to put in parentheses. Otherwise, it can look confusing. Anyways, 2/3 times 2/3. 2 times 2 is 4. 3 times 3 is 9. Cannot simplify that fraction any further. That's it. 9 squared. Remember, you do the 9 square first, and then you put a negative to it. So 9 squared is 81, and then you make it negative. So that's our answer. All right. Square root of 100. Well, square root of 100, what times what equals 100? It's 10, and it's negative because there's a negative right there. 0.81. What times what equals 0.81? I believe it is 0.9. Because if you do 0.9 times 0.9, you get 0.81. 9/16. Well, you can look at this a couple different ways. You have to do the square root to both sides, or sorry, not both sides, but the top and the bottom. So it's the square root of 9 over the square root of 16, by the way. So yes, you can write it as one big square root over the whole fraction, or you can separate it into two fractions with square roots on top. Sometimes that can actually be really, really helpful. Anyways, this to me looks easier. What is the square root of 9? It's 3. What's the square root of 16? What times what equals 16? It's 4. So 3/4 is your answer. By the way, the answer to all of these square roots is technically, in this case, plus or minus 0.9, and this one is technically plus or minus 3/4. Okay, just so you know, and that only applies to the square roots. not the squares rule. Almost always be positive unless there is the negative on the outside, like we mentioned before. All right, we are going to evaluate cube roots now. We've got negative 5 to the third. Remember, that's negative 5 times negative 5 times negative 5 again. So I like to determine first whether my answer is going to be positive or negative. Well, a negative times a negative is positive, but times a negative again, that gets us a negative. Remember, an even number, like 2, an even number of negatives is going to give you a positive answer, but an odd number of negatives, like 3, is always going to get you a negative. So our answer is going to be negative. And 5 times 5 times 5, if you don't remember, you can always check up here. Oh, look, it is. Look at that. 5 to the third. 5 to the third is 125, so our answer is negative 125. 1/4 to the third, so we have 1/4 times 1/4 times 1/4. Well, I know 1 times 1 times 1 is 1. 4 times 4 times 4. Well, let's check up top. Oh, there it is. 64. 4 times 4 times 4 is 64, so 1/64. All right. Notice that I'm not saying it's plus minus 64 because that doesn't apply to cube roots. It only applies to square roots. Negative 10 to the third. Again, you do the 10 to the third first. Whoops. You do the 10 to the third first, and then you apply the negative afterwards. So whatever our answer is, it's going to end up being negative afterwards. So 10 to the third is easy. I don't need to look up. It's 3 zeros, and then make it negative afterward. Super simple. Not radical, but cube root of 216. What times what equals 216? I better check my list because I'm not very good. Oh, there it is. It's 6 to the third. 6 to the third equals 216. Therefore, this is going to be 6 because 6 times 6 times 6 equals 216. We've got a little negative out here, so we know our answer is going to be negative, and we are looking for the cube root of 512. What is the cube root? What times what equals 512? There it is. It's 8. So we have negative 8 as our answer. All right. We're going to do the cube root of 1. I like to write it like that. Cube root of 1. And underneath the cube root of 27, it just kind of is easier for my eyes to look at. What times what equals 1? It's 1. That one's easy. What is the cube root of 27? I know that one. It's 9. Oh, sorry, it's not 9. It's 3 because 3 times 3 is 9, and times 3 again is 27. So it's 1/3. All right, we've got 2 more questions. We are looking at some word problems. A group of 225 students need to be arranged in a square formation for a halftime performance show. How many students should be lined up in each row? So this is kind of a weird question, but you see that square formation, they want some kind of square or square root, so it has something to do with that. So there are 225 students, and they are going to be in a square formation. So if there's like, let's 1 student, 2 students, 3 students, 4 students. You see those 4 students make a square? Let's say I do 3 students in one row. That means 3 students in the column. 4 students. That means 4 students like that because you still have to keep the square. So how many students do I have so far? I have like 4 here and 4, 4, 4. So 4 up and 4 across. That's like 16 because 4 times 4 is 16. What if I had 5 students and then I had to make another row? 5. That's how many students is that? 25. What if I did 6? I have to do 6 up here. That's 36 students. How many students am I going to end up having total? 225. So it's almost like an area of 25. Imagine you've got this square, and there are 225 students in this square. And then it's got the same length and it's got the same height. What are you going to be using to find the how many students are in the length, the width, and the height, how many form each row? You'd be taking a square root. So you take a square root of 225, and I actually remember that one from above, and square root of 225 is 15. Now you may be thinking plus or minus 15, positive or negative 15, but think of this. Can you have negative students? No, you can't. So negative 15 doesn't make sense. That's why we call the positive one the principal square root. So how many students should be lined up in each row? Well, if you had 15 students in each row, 15 here, 15 here, 15 here, 15 here, going up all the way 15. So 15 times 15, does 15 times 15 equal 225? Yeah, that's exactly what square root is. A square root is. So you should have 15 students in each row. All right. So yeah, square formation, 225. That should be kind of the key that lets you know, oh wait, square root. All right, the volume of a cube is given below. Find the length of one side of the cube. Well, I just want one side of the cube. We don't want like the length of all the sides, like some kind of weird 3D perimeter. We just want one side length. So how do you find the side length of a cube? Well, cube, side length, volume is here. That should give us a hint. When we have a cube, we want a cube root. You don't want a cube 729. That'd be crazy. So we are going to do a cube root of 729 to figure out what one of the side lengths is. Because remember, for a cube, to find the volume of a cube, you multiply the base or the length. I guess you can call it the length and the width and the height. And because it's a cube, it should all be the same number, right? So it's like some number times some number again times some number again. So it's the same number times itself 3 times, which is like a cube. So what number times itself is going to get you a volume of 729? I don't remember what it is. Let's take a look. Oh, there it is, 729. It's 9 to the third. So that answer is 9. And you could even, 9 what? 9 inches, I believe. And you can even check to make sure, like, hey, if the length was 9 and the width was 9 and the height was 9, 9 times 9 is 81, and 81 times 9 is, yeah, 729. So that's how you do it. And that's it. That is squares, square roots, cubes, cube roots. Hopefully you get it. Go ahead and try some problems on your own.